Bismillahirrahmanirrahim. Welcome to the next lecture of multimedia and technology and its applications. So today we are going to be study about digitization. So digitization is a new technique in a communication system to how to make a brightness, how to change the graphics, how to change a kind of a picture from a bright picture to the colorful picture, like you guys saw in the old ages, there in old time, like a black and white television or black and white picture. So digitization can make changes in your graphics. So this is just simple way that word, optics, then sensor, then signal is converted to digitization. At the end we have a digital representation. It's just a simple detail about how the word is getting to be changed. Okay, so coming to define a pre-digitization image. So if you have a image, pre-digitization image, so how it can be look. So the question is, what is an image before we digitize it? وقتی که شما یک ایمیج که دیجیتایز نکرده بودین او چطور معلوم میشه؟ دیگه سه چیز مهم است. او اول the continuous range of wavelength می باشه. continuous range of wavelength معنی چی میده؟ فرض که شما یک سینوسایدل ویو دارین، فرض که اینمی ویو که میبینید اینا continuous میگه که هر نقطه به شما یک ویلیو میده. So this is called continuous range of wavelength. Another thing is two-dimensional extent. So the images, as you said before, digitization date will be in a two dimension mean it will have a x component and it will have a y, and this is called two dimension. Okay, then the third thing is continuous range of power at each point. So if you can see this continuous range of wavelength, so it can give you a power at each point. So before registration it look like that. So another thing is brightness image. So again the same concept is applied here. So to simplify, consider only a brightness image. So again it will be in a two-dimensional continuous range of location, as you said, as you saw previous. So continuous range of brightness value, again the same concept will be applied. Continuous at each point you can get a value of power, at each point you can get a value of whatever you need it at instance. So again this is equivalent to a two-dimensional function over the plane. So move on to let's see, we have a image. So if you can see this image, and image is a surface. Look that you have an image, on the surface of image you have another image. So this image can call it be a surface. So this image, how we can describe in digitization. So if you can see this image, it's a black and white kind of a image, and you can see a small ball like that. If you are going to convert in digitization, so it will look like that. It will have a color, it will be look like a three-dimension. If you can see, it's like a three-dimension. Like what kind of three-dimension mean? Like this is your y, this is your x, and this is your z axis. So three-dimension mean you have a three axis, x, y, and z. So this is a basically the advantage of digitization. So now we can see how we can make the black and white to the colorful image. So we will see later on. So now the question is, how do we represent this continuous surface efficiently? So now this is the main thing. Now you can be like we can calculate bits, number of level in a bit, then we can create a image. So one thing keep in mind, when you are increasing number of bits per level, so your image is going to be colorful, your image will be clear, your image will be like a 3 dimension, like 5 dimension, as you guys hear from market that we have a 3D movies, 5D movies, 7D movies, and so on. So it's all so based on the number of bits per level. So we will see now. So coming to the discretization. So again the same thing, how you can make a digitalization signal. So you can so one first thing is sampling strategies. What is sampling? So you know about sampling, you studied in data communication as well, to make a sample of an analog signal. So if you have an analog signal, continuous signal, so you can make a samples. Okay, like I think you studied in data communication in a PCM, pulse code modulation, I think so. So there was, you can make a digitization, take a sample, take average value, then so on. So in a sampling strategy, the first thing is a spatial sampling. What does it mean? So it means how many pixels you need it for a graphic, you need it for an image, or you need it for a movie. The second is what arrangement of a pixel. So what kind of arrangement you need for a pixel. Okay, so later on you will know about the pixel now. So again the pixel is number of a bit per level. Yeah, how many level you have, and then how many bits you have in a level. Then another thing is brightness sample. So first we took the spatial one, then now it's a brightness. So in a brightness, how many brightness value. So again brightness value is again related to the number of bits. Then spacing of a brightness value, again it's spacing, so again number of bits per level. So each and every single thing as you are studying here, it's based on a number of level, and it's based on number of bits. Everything is based on a bit, so keep in mind this. So for a video also the question of a time sampling, so again number of bits will be here. So now if you can see this example, so in this example we have a project through a pixel. So if we have a digitized film or slide which have a 35 millimeter of a value, so once one of the array or a signal or a light can be transferred from this film, so you can see after passing it, you can see like an image. So so central projection array means, so when a signal is passing from the mid of the film, so when the mid of film is passing, so maybe you studied it is a elastic collision in a physics, whenever the central of a one object will be in the same line of the another object, so you will have a elastic kind of you. So what does it mean? It means that when both central or what can say when both the center of the object is linear to each other and like face to face, then the energy of a one object will totally transfer to the energy of the another object. It's called a law of conservation of energy. The energy will be converted from one object to another object, but energy never be created and not destroyed. So energy never be destroyed, so it just changed from one object to another object. So and the same thing, when it's passed to the central, then you will have a complete energy here. So the image will be showing here. If you saw the old television, there was kind of a cathode tube. The cathode tube was a emitting a ray, so that was the image of old televisions. So image radius is the average of the seen radiance over the area of the surface intersecting the solid angle. So why he saying this? Chara mega وقتی که نمی central ایزمی signal از central پوست شد دیگه کلش انرژی یک آبجکت تو دیگه آبجکت میره و شما که کدوم امیج میبینین، کدوم ویدیو یا کدوم گرافیک میبینین، او 99.99% کلیر میباشه. از این خاطر میگه که central projection array. اوکی. So now coming to the signal quantization. So you know about the quantization, you studied in PCM and data communication as well. And signal quantization means you are making you are taking the value of a signal. How it can, like you have an analog signal, determine a mapping from a continuous signal. So for example, analog video signal to one of a k discrete value. K discrete means digital discrete or digital value, a digital level. So let's say this is your analog signal. So analog signal or continuous signal, it means that you can have each value on each point. So this is called analog signal. So if we can say this value is equal to 0.1583 volt, let's consider this is equal to 0.1583 value. So when we are going to digitalize, so what can we do? We can fix the range for the value. If we say it's a 0.15, so we can, when it's more than 0.5 or it's more than 0.1, so the value will calculate to be 0.5. So it means we will consider this thing is 0.5. It's your consideration how you want to make your quantization. It's up to you. Can be considered to 0, you can be considered to 0.5, you can be considered to 1, but taking a small value will be accurate for a clear signal, for a clear graphic. So what will be digitalized value? It's up to you. So now this is the important thing for a quantization, because we have a number of level, we have a number of bits. So again the same thing is continuously, we had a continuous signal in above 1. So the continuous signal will be start from greater than or equal to 0 and less than the maximum value. Then want to quantize to k value or digital value. So it can be 0, 1 to k minus 1. K is your digital value. So it can be 0, 1, 2, 3, 4, it can be 0, 0.5. It a quantization value, you can consider it. If you guys want to know about it, so just go to your datacom book and see the PCM digitalized value. So then k usually chosen to be a power of 2. So one thing which is more important here, how we can find number of bits or how we can find number of a level. So finding a number of a level, so we have a formula log 2 and number of bits. So you can easily find by this formula number of a level. You studied in data communication, again the same thing. If you have a number, if you have a 1 bit, so if you have one another formula as well, 2 raised to power n. So 2 raised to power n mean if you have a 1 value, 1 bit, so 2 raised to power 1 is equal to 2. Then if you have a 2 bit, 2 raised to power 2 is 4, 2 raised to power 3 is, and so on. So if you want to find, like let's say you have a 8 bits, okay, you have a 8 bits. So sorry, this formula is going to be a little bit confusion. I can make it simple. So if you want to find a bit for number of a level, so finding a number of a bit from a level, so log 2, okay, and so if you want to find a number of a bit per level, so this formula will be used. So what can be used? So how many bit can be in a per level? If you have a level 8, if you have 8 number of a level, so log of 2 raised to power 8, so just simply 2 raised to power 3, so your answer will be 3. So you have 3 bits per level. So this is basically a way. So this is a method how you can find. So once you have a 128 level, so how many bits you have? 7. So when you have 256, then you have this one. So this is the method when you are going to increase your number of levels, so automatically your number of bits is going to be increased. Or if you are going to increase your number of bits, so your number of level is going to be increased. Okay, so this is more important. If you want a good signal, so you need to be increase your number of level, you will increase your number of bits. So if you want a black and white image, so no need to be increase your bits and level. So if you need a HD kind of a picture, so you need to be improved. So later on we will see how it can work. So mapping from input signal to output signal is to be determined. So several type of mapping. So we have a uniform, we have a logarithmic, etc., etc. So now you can see choice of a K or choice of quantization. Okay, so once it's your image, original image, so we are going to be a linear ramping. So you know about ramping, we studied it. So okay, whatever we are going to do now. So once your K value is 2, what your K value is 2, so we have a 2 kind of color. When you have a K value is 4, then 4 kind of a pixel. It's just like a pixel. When you have a K is equal to 16, you have a 16 pixel. Then you have a K is equal to 32, so you have a 32 pixels. So what does it mean? If you have a 2, if you have 4, if you have 16, if you have 32, so just take 2 raised to power n formula. So for K is equal to 2, it means you have a 1 bit. For K is equal to 4, you have a 2 bit. For K is equal to 16, you have a 4 bit. And for K is equal to, it means you have a 5 bits per level or per bit per pixel. So once your number of bit is going to increase, your number of level is going to increase, so your image is going to be clear and clear. So that's why I told in previous, so number of level increasing, number of bit value increasing for your clear signal, for your HD kind of a signal. So now this is the clear example of a value of K. Now choice of K. So it's your image. So you took an image from outside, so you are going to be make it clear, or you are going to make the pixel how it you can see it in the future. So once you have K is equal to 2 for each color, so you can see the image is going to be changed in this shape. Okay, so because just K is equal to mean you have just 1 bit, so how it can work so bad. So if you can see, even it doesn't be see that it's this picture. But when you are going to increase your number of a level or bits, so K is equal to 4, so it means you have a 2 bits, so each color will have. So now this picture is a bit clear now, not good but bit clear. If you want to be more clear, so K will be 8, K will be 16, K will be 32, and so on. So again I'm telling you, later on we will see one by one. So now coming to the choice of function, which is uniform and logarithmic. So first we are studying about uniform. So what is uniform? Uniform sampling divide the signal range from 0 to into K equal size interval. So each and every level will have a same distance, same number of a bit, and so on. Okay, that's why it is called a uniform. So integers start from 0 to K minus 1 are assigned to these intervals just mathematically for method of how we can make a digitization. So all signal values within an interval are represented by the associate integer value, define a mapping. So simple is that. So you have a signal value start from 0 to m, then you have a quantization level 0, 1, 2, 3, 4 up to K minus 1. Simple is the method. So once you have a signal value, let's see this 2, so your digitization will be maybe 2 or 3 and so on. So this is a method simply how. So uniforming, so the each and every K value will be equal and a size will be the same. So now coming to the logarithmic quantization. So in a logarithmic, so the graph is going to be like a elliptical. So signal is in a log form again. So effect is will be, so your signal value is this one. So quantization level is 0, 1, 2, 3. But the image is going to be a bit changed now. If you can see the above one, if you can see this one, this was uniform because each and every value is going to be equal. So in a logarithmic, the graph is going to be curved like elliptical. So this is basically when you are drawing the graph of a logarithm, so it's look like that. So this is basically 2-3 methods how we can be quantized, maybe uniform, can be logarithmic as well. So detail and hints in the low signal value, it expands of a detail in a high signal value. So now what's the difference between uniform and logarithmic? So in a logarithmic, if you can see here, so your image is going to be more clear. So this is your original signal, this is your RGB red, green, blue channel kind. So whenever you are making kind of, so we can use RGB red, green, blue concept. So later on we will see again this one as well. So your input will be 45, your output will be this, your graph will be sinusoidal kind of, and you're making your logarithmic. So after assigning a bits and level and so on, our digitization value, your final result after logarithmic quantization will be so clear now. So if you can see this, so this picture is more clear than this one, original one now. So again, now you guys understood that how we can make a good signal, how we can make a good video, how we can make a good pixel, or how we can make a HD signal. So this is the way how to increase the number of a bit level and quantization. Now this is the most important part. Let's see color display. So given a 24-bit color image, so 8-bit each per RGB, I told you, red, green, blue. So you can see here red, green, blue just. So more important is turn on 3 sub-pixel with the power proportional to RGB. What does it mean? So 8-bit, what does it mean by 8-bit? 8-bit, so it can be 8-bit give you a signal number of a level. So in R, in a red you have a 8-bit, in a green you have a 8-bit, in a blue you have a 8-bit. For each color you have a same number of bits. So you have a TV CRT graphics, PC CRT, X01 LCD graphics, and LCD. So which one is more clear? So if you can see, PC CRT is more clear than this one, and this is bit off. So it's totally based on the quality now. So the bit is same, but the quality is going to be changed because the technology is going to be changed. So now we will see how it's going to be works. So now if you can see this, so everywhere you can take a 3-way, 1, 2, 3. Then you can see 1, 2, 3. Red, green, blue, red, green, blue, red, green, blue. So here red, green, blue. So a signal pixel with the 3. One signal pixel will have a red, green, blue, red, green, blue. And you know, a red will have a 8-bit, green will have a 8-bit, blue will have a 8-bit. So totally 24-bit. So 24-bit of a color image. So you can say 24-bit color image. So it will be looks awesome, nice, and clear as well. So just for your understanding that a white text on a color display, just simply a sample. So in the sample there will be just a white color, not red, green, blue, etc. Just a white color at the end. So it will be look like this one. It's just for your understanding. So just for a color selector. So if you are going to select a color, for a color we have a number of a bits. So for each and every kind of a color we have a different number of a bit. For red, green, blue, white, yellow, purple, and so on. For every color we have a different number of a bits. So if you study that in a MATLAB you are finding a frequency of a color, or you can find a frequency of an image, or you can find a frequency of a number. So everything will have a different frequency. So when the frequency is going to be changed, it means number of bit is going to be changed. So you know about the frequency concept. So this image have a frequency. So whenever you are going to be take this image in a MATLAB, so MATLAB will show you the graph like in image in a frequency way. It will show you this kind of MATLAB will show you this kind of a graph which show the frequency of a image frequency. Also if you can take this number, if you can take this in a MATLAB, so this color selector will have a different frequency because C is a different alphabet, O is different, L is different, even so every and also the color is different. So this is the basically alphabet, so you know about ASCII code, so it will be work on based on ASCII code, but when this is the color, so the color is going to be changed. Okay, so coming to the construction, color LCD display, like a C movie, if you are watching a movie, so how it can work. So in this image, so in this table we can see how we can calculate to make a grayscale image, a colorful image. So 8-bit image, okay, when you have a 8-bit image, so 2 raised to power 8 is 256 different values, so you have a 256, so you are taking a 255, start from 0 to 255, have a number of our level and different value. So simplest way to display, simplest way to map each number to a gray value. So what is the scaling of the for a gray value is, so 0, which is will be in this, so 0 0.1, 0.1, 0.1, okay. Then for a 1 it can be 0. This is basically the fixed scaling for a grayscale, no need to be changed, or you can be select up to 1 1 1. Then start 2 to 2, then it will be this value. So this is a actual and the fixed value scale. So this again 255, 1 1 1 and up to this one. Okay, so this is called a grayscale image. If somebody can ask you a grayscale image, so you can draw and write this scaling. Okay, so now you can look the difference of a different images of a different number of a bit. If you can see image of 8 with the 8-bit gray color lookup table, so number of bit is less, so the image will be showing in this way. Okay, if you can see, so it's like a black and white, you cannot be say what kind of color is there now. So when you are going to be increase your number of bits, so the true color will be, so if your image and you have a 24 bits and the method of RGB, red green blue, so the red green blue, so the because 24 bit you use for red green blue concept. Okay, so red green blue concept, so you can see 3 different colors now, and this is your colorful image. If you can see 8 bits, so 8 bit is not going to be for, it can be for a red, can be for a green, can be for a blue, but you have a just 8 bits, so it's going to be mixed. So when it's going to be mixed, so this will be in a black and white. So this is a programming how you can make it. Image screen size, number of bits and so on, you know better than me this programming. So for a non-gray lookup table, this is for a non-gray app. We can also use other mapping 0 to 17, this is the fixed values for one, this one too. So if somebody is going to be all for non-gray lookup table, so you need to be draw this one. Okay, so this is the another image where more lookup tables. So in table, as you said, a colorful gray and non-gray table. So when a gray table is going to be improve or increase in the number of bits, so your image is going to be changed from this to this. So it can be changed from this to this, then this can be changed from this to this. It's based on, totally based on increasing a number of bits. Okay, totally it's all whatever you are going to be seeing technology, it's totally based the game of a bits, game of a level, game of a bits. Bits is going to be increased, your graphics, your image, your video is going to be better. Then fun with a MATLAB. So in a MATLAB, whatever you want to do, you can do it, and you already a bit study about MATLAB in your programming view as well. So in a MATLAB, just take whatever kind of a picture, just determine it in a MATLAB, finding the frequency. So in a MATLAB, it's like a game. Whatever you want, just remember the command, take a command from Google and just run it out, you will have a different kind of output. So whatever you want it, you can do it, like how the camera is going to be scanning the number plate of a car. There's a number, so they're just taking an image of a number plate. It's coming to this programming in a MATLAB way. There's a, so it's going to be take a frequency of a number, and that frequency is going to be synchronize and demodulate and decrypt, then it will take a number again. So it's a game of a MATLAB totally. So see you in the next lecture. If you guys find any kind of a question, you can ask. I'm willing to answer that. So this is your new lecture. So see you in the next lecture. Thank you for your time.